see what we can learn, or what you scored on it, right? So we have this maple leaf here. It's made out of 11 equilateral triangles. Like, that is important, that wording, equilateral, will give something away there. What's the measure of angle A? So they want A here. And we know that an equilateral triangle, we know that all sides are going to be the same. And we know that all angles inside of it measure 60 degrees. Right? So therefore, A is equal to 60 degrees. Okay, so angle A is equal to 60 degrees. If you have 60 on there, you get the mark. Okay, for A. The measure of angle B, B is right here. We know that this is 60. And we know that both of those angles are along a straight line, right? So these two add up to 180 degrees. Right? So therefore, B is going to be 180 minus 60. So angle B is really 120 degrees. So a lot of these questions, you'll find that knowing properties, knowing what is true about just them giving you certain, terms, that is going to get you started. Okay, so we know that every single one of these triangles is an equilateral triangle, right? So every corner that you find is going to be 60. B is 180 because it's along a straight line. So this is already, we learned this in when we did trig, so you should be comfortable with that. C, state, right? You have to tell me what type of quadrilateral is formed by combining triangles X and Y. Right? You're combining these two together. And think about it. No matter where you go, if you look at this triangle here, we know it's equilateral, so all three sides are going to be the same. If you're looking at this triangle here, we know that this side is going to be the same as this side, is going to be the same as this side. So now let's just highlight the shape that is formed when you put them together. The question did that already, in a sense, right? If you combine this, what do you get? And don't say diamond, right? We did not study diamonds, right? We studied, this one would be a rhombus, right? Because if you think about it, it's a slanted square. So specifically, right, all sides are the same. So specifically a rhombus. If you put down parallelogram, or I guess parallelogram would be the word that some of you would have used there. It has to be specific, right? As specific as possible. And if all sides are the same, it goes beyond the parallelogram. It is actually a rhombus, right? So that's the mark there. So for question 1, you get 3 marks if you get all of that right. You don't need the diagram. You just need the word there, rhombus. Okay. Let's keep going. Question 2. Squares and parallelograms are geometric figures. Using properties of polygon, explain why a square is a parallelogram. Why is that true? Well, think about a square. What a square, you can easily just say, hey, it's all sides are the same, all angles are 90s, and this side runs parallel to this side runs parallel to this side, right? These two are parallel, these two are parallel. So a parallelogram needs to have, like, one of the properties that they share in common is that it has two pairs of parallel sides. If you said that, you get the mark already. You could have also said 2 pairs of congruent sides, or equal sides, because this one, these two are the same, these two are the same. In a square, they're all the same, but you can still say that it has two pairs of equal sides, right? So that is also something that you could have mentioned there. That's why a square is also a parallelogram, because these two are true for a parallelogram and for a square. Okay, so you get 1 mark with either one of these entries. Okay. B, explain why a parallelogram is not always a square. And this is why, because a parallelogram, if you think about it, right, this is the exception. This would be the classic diagram of a parallelogram, right? So you could say does not always have 4 right angles. You can say that, right? A parallelogram does not always have 4 right angles, okay? And you could also say does not always have 4 congruent sides. So you're stating why it's not always possible for a parallelogram to be a square. So either one of these would get you the mark there for 2B. Okay. Question 3. Pedro's building a triangular roof for a house. He would like to build it as steep as possible so snow does not accumulate on the roof. So one set to fall off, right? State whether Pedro's roof should be equilateral or isosceles. Which one should it be? Well, think about it. If it's equilateral, it has to be 60 everywhere. You can't make this any steeper if you wanted to. You can't adjust it. You're fixed, right? So all you have to say here is isosceles. You don't have to explain why, but it's the isosceles because you could make it really steep, right? As long as these two angles are the same, you can adjust the top. Right. The smaller the better, exactly. Okay, so that's the answer that you're supposed to have put down here. Justify your answer in A. With an isosceles triangle, you can adjust the top angle, making it steeper. And if you wanted to say with an equilateral, you're fixed, you cannot change it. If you said something like that, that is also good. If you said an equilateral triangle will not allow you to change the angle, so you're stuck, right? Yeah. So question 3 is out of 2. So far we are what? 2, 4, and another 3. So we are at 7 so far up to question 3 for this page. So a lot of properties, knowing what's what, right? That's why you need your study sheet on this one. Backside, or number 4, a kite is a type of polygon. Polygon is just a word for, we're going to talk about that a bit more. It's many sides, many angles actually. Polygon means many angles, right? So a triangle is also a polygon. State 2 properties of this polygon. So property 1 would be 2 pairs of congruent sides or equal sides. Right. Okay, let's put that one down. Diagonals meet at a 90-degree or the fancy word perpendicular, right? The diagonals are perpendicular. So they meet like this. They meet at a 90. You could say that one of the diagonals is bisected. If you put that down, that is a property. It has one pair of congruent angles. That's also a property. So, but you only need two. Don't put two. This is the danger. Some students want to load the bases, right? It's like I'm just going to put everything down, and if one of them is wrong, then I have to take marks off. That's how we mark it, right? So don't just put stuff down if you're not sure. Don't do that. It can actually affect you. Okay, so 2 marks, by the way, for question 4. 2 marks. So if you have two properties that are true, then you get the marks. I want to maybe take a little side here, an aside, an extension. Why would a kite not be a parallelogram, right? If they asked you that ever. The main reason would be it doesn't have two pairs of parallel sides. It needs to have, like, if this side would be parallel to that side and this one would be parallel, then yes, it would be parallelogram, but in this case it isn't. Like, yeah, these two would have to be parallel. If it looked more like this, right, where this is parallel to this, then yes, you get to go, but it isn't, right? A kite isn't. So it's sometimes just kind of state the obvious and then you win, right? It could be a rhombus. Oh, I actually made a mistake here. There. This could be a rhombus if these two had been the same. If all 4 are the same, correct? Yeah. My markings were off here. It should have been like this. Yeah. Question 5. I did something like this in the book. I remember that. Okay. There was a bridge there. Students are solving math questions. There's a 100-meter truss bridge. The bridge is made out of 7 equilateral triangles. There's that key word, right? Equilateral. That means that these stretches will all measure the same, right? And same with these sides. Like all these triangles have congruent triangles. Sketch one of the bridge's triangles and state all side and angle measurements. So sketch, that's what it is. You don't have to make it fancy. We know that the angles are going to be 60 for sure. And now we need to figure out the side lengths. Well, let's just focus on the bottom here. 1, 2, 3, 4 sections across. So 100 divided by 4 is 25 meters per section. Right? So every single section here will be 25 across. And that also tells us that every side of each triangle will also be 25. Okay? So 25, 25, 25, and 60 in each angle. That's what I'm looking for. So if you did the angles, you get 1 mark. If you get the sides as well, you get the 2 full marks in your diagram here. Okay, so that's what 5 is all about. So again, it's not crazy math, but it's knowing your properties, right? Consider the isosceles trapezoid. That's a key word right there. It's not just any trapezoid, it's an isosceles. That means that this side is the same as this side because of this. Right, this is very important. That's how I got that figured out. And because the trapezoid, you also know that this side is parallel to this side. And so x is just going to be the same as the angle, the base angle across. So that's 70 degrees. You get 1 mark for that. And y is 2.5. You get another mark for that. How is that? right? You just have to know that that's the case because I gave you the name of that shape. If it had just been a trapezoid, you're not guaranteed these two sides being the same and these two angles being the same. Okay, 2 marks right there for 6A in a sense, right? That's 6A. And then find the area of the trapezoid. I gave you the formula for it. I'm gonna make this. I'm not gonna include this because I didn't do this with you. A is for us is the bottom here, and B is the top, or vice versa. It doesn't really matter. I'm just gonna. I'm not gonna do this one. Omit, right? But I will still do it with you. Okay, so we'll do A is equal to half, so 1/2. So 6 plus 4 divided by, no, times height, sorry. 6 plus 4 times the height. And we would need to find the height of this thing. Okay, so we have to cut it. We know this is 2.5. 6 minus 4 is 2, divided by 2 is 1. So this is 1 here. So this would be, we can call this side A in a sense, or let's call it height, right? So height is 2.5 squared minus 1 squared. And that's 5.25 in root, under the root, and it's 2.2913 rounded to 4 decimals. And that's the height you use here. So 2.2913. If it shows up after today, then I do expect you to do it. When you have this, folks, watch what I'm going to do here. 6 plus 4 is 10 times 2.2913. Just divide it by 2. That's much easier. Yeah. So you will see this after high school. You might get formulas like that. Just put if this had been 2/3, it's times 2 at the top, divided by 3 at the bottom, right? So don't let that scare you ever. So let me see what we get here. 11.46 rounded. And that is in meters squared. All right. So this makes this if we omit this thing is out of 13. Okay, the whole thing is out of 13. So give yourselves a mark out of 13, and then I will ask you to submit this. And then we'll continue with our lesson. Okay, it's up now. Good to go. Yeah, everybody, even if you're in class, submit it online, and you keep the paper copy. And hold on, somebody wrote something there. Give me a second. Yeah, so Jinky, if you go 6 minus 4, oh, I'm going to stop recording.